All right, in this lesson here, what we're going to do is take a look at adding the enemy class.
Monkey!
We're going to be deriving from or inheriting from, come on guys,
Sprite.
as you remember from the picture we showed you all the way back in Photoshop. Now, the enemy, I'll give you one hint in regards to what the enemy is going to do. Joel.
It's going to attack me.
Attack you, yes, because he's your enemy.
Yes.
But to attack you, that means we've got to make this guy kind of smart.
Yeah.
Up to this point, we haven't made anything intelligent. Our character just takes some input and can run around and walk into walls and go, ow, 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 but that's about it, right?
Yep.
But now we need the ability to add an enemy in, and we need that enemy to seek you, to hunt you, to want to kill you. Yes, that's it. So we're going to have to add that functionality into it. And not only that, we're going to need to do another thing that's going to be quite interesting in this lesson, and that's add a list in because we need multiple enemies.
Yep.
We need a list of enemies. So we have a bunch of them tracking you down.
We could have 30,000 enemies in one level.
Ooh, that would be scary.
We wouldn't be able to move.
No.
We'd be dead before we knew it.
So we're gonna be doing some slight modification to Sprite and working with the enemy class.
Yep.
So with that, let's get started.
All right. So the
big picture.
The big picture.
Yeah.
The big picture is necessary. So first, what is an enemy? An enemy is just a sprite.
It's a monkey that
It's
was
a monkey.
part of a test lab experiment. It went really wrong, and Dan Bissell was the evil scientist that was running it. And
Yeah, and then 28 days later, we came up with this
evil monkeys.
Yeah.
My monkey minions. Yeah.
So
please.
an enemy inherits from Sprite, as we were talking about before, and we're just going to give it a brain. But the first thing is it's going to need to know who we want to attack, right?
Yeah, we want to be able to specify a player, which would be a character class.
That'll be Joel.
Right.
That would be Joel, that we can hunt down and attack with our evil monkey ways.
Right.
That's right. So we're going to have an add goal function so that we know which character we want to attack. From there, we're also going to have a function, which is going to be private to ourselves, called Simulate AI, which is going to basically just perform all the moving automatically for us.
And in case people don't know what AI stands for,
Artificial intelligence.
There you go. It's going to be very simple artificial intelligence.
Yes.
Yep.
And
That's what I function off of daily.
Yep.
Hello.
Oh, great. From there, we'll need to change move to reflect the enemy hunting behavior. So we have move, which is going to move the guy around.
Yep. Because that was a function that was defined inside of Sprite.
Right.
And we're going to have to take care of simulating the AI, but also drawing ourselves and moving
and all that
ourselves
stuff.
and all that.
So we'll also need to change idle update so that when the level lets us, we can hunt.
Yeah, we're actually going to add that into the Sprite class.
Right, something that constantly happens. We actually talked about it when we developed the Sprite class.
Yeah,
just
we
a
did.
little bit.
Just a little bit.
All right, so the data that the enemy will need, obviously the goal. Now, this bottom part here, this is going to be the things that we need to add to our level to make it so that it functions properly and uses our enemy class.
Yep.
So basically adding the enemies, so adding the bad guys into our level. Add an NPC, which basically just places a sprite onto the list.
Yeah, add a non-playing character for all you roleplay fans out there.
Yeah, non-player character. Is done, just checks to see if we have any sprites on the list. If not, game is done, because we killed everyone.
Yep.
So cycle through our list of sprites to call their idle update.
Yeah, which is what we defined in the last lesson, the very last function.
That doesn't do anything yet.
Oh, but it
Yeah,
will.
It will.
Yes.
So let's switch back over into .NET here. Woohoo! Inside of here, let's create our header file, because that's what we always have to do.
For our evil monkeys.
Our evil monkeys. Enemy
6.
Enemy 6. I don't know where that came from. Enemy.
Follow the rule.
Follow the rule. If not defined, then we're going to define enemy underscore age. Otherwise, we're going to define enemy underscore age. Then we're going to end off the if statement. Woo! All right. Now, inside of here, class.
Enemy.
And it inherits from public
Sprite.
Sprite, which means we're going to need to know about Sprite. So we're going to
Include time.
Include 3.
include.
It's a new keyword.
It's a new keyword. Sprite.h. All right. And then inside of here, let me put my semicolon so I don't forget. All
Public,
right.
private.
We're going to have our public section and our protected section. Protected.
There
Thank
you
you.
go.
All right.
Very good.
I know. I can
It
spell.
changes colors when you get it right.
I need to go back to high school. For more reasons than one.
Hi, Joel.
Okay, so we have our constructor, and we're going to pass it a few things. The first thing, just like we did in our sprite, we need to pass it our pointer to our level.
Yeah,
our
but let's
pointer, comma level.
Get
No.
rid of that comma, yeah. We'll need the draw engine again.
We need the draw engine. I really like this convention of how we have the level first and the draw engine. It just makes things so much easier.
Yeah. It always depends on how you think about it. If you happen to think that the draw engine is more important, you can pass it first. If you think the level's more important, You can pass that first.
And of course, we all know that the level is more important, so it only makes sense that we should pass that first.
Yeah, we're having a little bit of a coding war right now. And the crowd goes silent.
The crowd goes silent. I didn't know we had a crowd. Anyway, we also have our add goal function that we talked about before, so we're going to have to add that in here. Of course, we're not going to return anything, so it's just going to be a void. And we're going to pass it a pointer to a character.
Because the character class is going to be who we're hunting.
Right.
And if we happen to derive off a character, this will still work.
Yep.
Because character holds functionality that will be included inside of any future classes, like, say, a mage or a
fighter
or anything else.
And finally, we have our idle update function that we were talking about, which is going to be called to call simulate AI. So inside of here, we have our protected simulate AI void. Thank you. And we have our character goal. And of course, we're going to need to know about character, aren't we? So what do we need to do? In this case, we're going to use the class character method again, which predefines it.
This is because of the cyclical
thingy-majiggy.
Yeah, because if we included character right now, we'd go into character, which would include sprite.
Yeah.
Which enemy also includes.
Right, and then we just kind of go into a circular
thing that goes around.
Like I said, we're going to have a lesson just on this to give you some examples on how it all works. So we have class level as well, because right here we're using the level. Think. Alright, so that's it. This is our simple function. Now we just need to define all this stuff.
This is our simple class.
Our simple class. What did I say?
Function.
Wow. You guys catch all my mistakes. When I do anything right, you just conveniently log it back in your brain.
Yeah, we're quiet when you're right.
Yeah.
It's not as much fun.
Go ahead. That's nice. You created the CPP file with no problems.
Oh,
Will he remember what to do next?
That's the question.
Probably not, but I could try.
Okay.
What's the first rule?
Include
enemy.h. It's included.
Yay, us.
And now, alright, our constructor. Whoa, I meant the constructor. Our level, our draw engine, our integer s_index, as well as our float x, float y, and our int I_lives. And we're going to pass this to our sprite. Now I did an enter just for Dan. So we're calling the sprite.
And don't forget that he did put that colon
at the very end
of the line. Yeah.
In fact, let me just put this right here, and then just pull this up. May make it easier for some people.
Yeah, just in case. I just wanted to say that in case someone happened to glance away.
And then I put this magical colon there, and no one saw it.
Yeah.
It's like, wow, you have an extra colon.
You do? I'm sorry.
Wow.
All right, so we have this all set up here. Now we just need to do one simple thing. Goal equals 0.
Because we haven't defined it.
Yeah.
Yeah. It's null right now, which means we haven't made an assignment. So if we decide to check, we know whether or not we have a player or not that's been added to.
So inside of here, we're just going to say class ID equals enemy_class ID, right?
Which we'll have to add inside of
Sprite. So inside of Sprite, let me just quickly add this. So right here, I'm going to say enemy class, and what value is this going to be?
I'd say 2.
Yep,
yeah,
because first one's 0, 1, then 2.
All right, so back to our CPP file here. That's the simple constructor. Now, now we have our move function. This is where things get a little bit interesting, don't they?
Our enemy must be able to move.
Yes.
Yeah, it's really not that interesting since we broke it up into simulate AI and move.
Right. So what I need to do is just declare it. So bool enemy move you.
And again, we're going to be responsible for moving, seeing if we can move.
Right.
We have to see if we can move on the level.
So just like we did before, we're going to declare a temporary variable.
Because this is the position we intend to move to.
Right. Copy, paste.
Joel doesn't want to type that all out again. I don't blame him.
All right. So if is valid level.
And remember, we made this is valid level move back in Sprite.
So now we're saving time.
Yeah, it's very convenient now.
All right. Inside of here, what do we need to do? Let's see here. We need to check to see... Well, actually, let me just type out erase, just like we did. Actually, you know what?
You're going to cut and paste, aren't you?
I'm going to cut and paste.
Yeah.
So in our CPP file, if we go down to here in our move, just going to take all this, copy it, come over to here, paste it in.
And so we're just going to add what we need to add.
Right. And the only other thing that we need to do at this inside of our move that's different from everywhere else is what? What do we need to check for?
We need to see if we
bumped into
anything, which would be another enemy.
Another enemy of some sort.
Yeah.
That's the only difference. So right now, we don't have any other enemies, right?
That's true.
So we're not going to actually put that in here.
Let's put a comment in right now.
Let's put a comment in here. Agreed. So right here, make sure we don't run into any other enemies. Right? Because that would be stupid if we did.
Which is something that we're going to add once we are able to have more than one enemy on our level.
That's right.
Yeah.
Now we have our idle update function. Enemy, idle update. And we're going to pass it void. So if we have a goal, so if we have something to attack, simulate AI. Because we want to call simulate AI, which will actually do the thinking for us and move our character.
And the reason we're doing it this way is that idle update is going to become part of the Sprite class.
Yes, it is.
And since that is part of the Sprite class, everyone derived from Sprite knows about it.
Right.
So if anybody wants to call it, we have a function that everyone who knows about Sprite knows about this function.
Right.
And
so
they won't know about simulate AI, though.
Yeah.
So it's kind of a generic way of getting our functionality in through using the virtual keyword in our Sprite class.
Very cool. So now we have our idle update. Now we're going to do a simple accessor type function, which is add goal. It's not an accessor. It's a, what is it, Dan? What's the special name for this?
A function that adds to our class a variable assignment.
That's like mega tech right there.
Yeah. I'm trying to remember accessor and geez, I can't remember it today.
That's okay. I don't remember either. So inside of simulate AI, this is where the magic happens. This is where we're going to actually have our character think. All right. So how do we do this? Well, let's try to explain it first, how we're going to do this.
Yes, we should explain it.
We have our character. A character has a position.
Yes.
Our enemy has a current position. Well, we can determine how a vector. What is a vector, Dan?
A vector is a direction in space.
Is a direction in space. So a vector points at something.
Yeah, it'd be like if I had a big stick and there was a tree over to my right.
Yeah.
I could turn myself so that I point the big stick towards the tree.
Right. Very cool. So what we want to do is have our enemy point at our character. And once we know how to point at our character, we can start moving towards that character.
Yes.
Right.
Because we have a line of
pointing,
motion. We can move along that line to get to the character.
That's right. And if we just use simple subtraction for this, we can do this, right? Right?
Yeah.
We can simply say character's position minus Dan's position, and I'm going to go directly to Dan, right?
Yeah, it's doing some vector mathematics.
Mathematics, right. So let's just go ahead. Does that make sense to you?
Yeah, it does.
All right, so inside of here, we're going to say vector goal position. This is the position of the goal. So goal get position. Remember one of our accessor functions that we created back in the day. Now we also have our vector direction. Vector direction is what we're going to be calculating. Now here's some simple vector math. Goal position, where we want to move to, dot x, minus our position, dot x, right?
Yes.
So direction dot y equals goal underscore position dot y minus position dot y. Simple enough, right? So now we actually are moving towards the direction we want. But here's the problem. If we do this directly at this point, and we add this to our current position, what's going to happen? Well, we're going to move directly to our character.
So which means we could be moving diagonally.
We could be moving diagonally, anything. The problem that we have here is that he's going to directly, the length, how far he's going to move, could be anything. He's going to directly get on top of the character. That means our character, our main player, has no chance of survival.
So the enemy could jump 10 spaces, and it would be right there.
Yep.
Okay, I understand.
So now we're going to create a float magnitude. A magnitude is basically the length of our vector. So how far is he moving? Well, if we take our vector and divide that by our magnitude, we're going to get a unit vector, which means the length is only 1.
Yeah, which is what we want.
Which is what we want. We only want him to move 1 space at a time.
And in vector sense, it's the same vector.
Yeah, it is the same vector.
It's just we've scaled it back so
he's
that
still
it's
pointing in the
one.
same direction.
Yep.
So from here, we're going to say square root. This is the square root function. If you guys all remember the great, what is the theorem, Dan?
The Pythagorean theorem.
Yeah,
I like to call him Joe.
Oh no!
This goes back to my high school days with Tom Campbell, great math teacher, and we just called him Joe.
All right.
Pythagorean theorem was Joe.
Yeah, the square root.
I actually tried to ask him what Joe stood for. Joe doesn't stand for anything. It's just Joe. I don't get it. It's like I never heard of that one. So all it is x squared plus y squared, the square root of it.
Right.
So direction dot x multiplied by the direction dot x plus the direction dot y times the direction dot y. Isn't that difficult?
That's it.
That's all there is to it.
And a semicolon.
And a semicolon. So let's put a semicolon there. So now we have the magnitude. We just divide direction dot x and direction dot y by the magnitude. So we can say direction dot x equals direction dot x divided by mag. Direction dot y. Whoa.
Direction.
Thank you.
You're welcome.
Dot y equals direction dot y divided by mag. Simple enough.
So now we have our unit vector, which is pointing still towards the direction of our player, but it is a 1 in length.
Right. It's 1 unit. So what can we do? We can say if we can't move to direction dot x, direction dot y, because remember we have our move function. Then, if we can't move, then what we're going to do, see, when we call move, all right, it's going to return true or false.
Yeah.
So if this succeeds, we're just going to exit. We're going to finish the whole function. If it doesn't succeed, we're going to have to try. That means we're hitting an obstacle.
We need to find some way around it.
We need to find some way around it. Well, we could use some nice pathfinding techniques, but you know what? We're going to make this guy through trial and error. He's going to go, let me see if I can go left, right, up, down, all around. You know?
This is a brute.
So this is a brute force method. So we're going to say, while he cannot move in what direction, we're going to create a random value between -1 and 1 in x and y. And to do this, we can simply say random modulus 3. So that's going to give us a value between 0 and 2, right? -1.
Which will give us a value now between -1, 0, and 1.
Right, -1, 0, and 1. So now we have that, and in our y, we do exactly the same thing. Like that. Simple enough, right?
Yeah.
Seems simple to me, at least.
I understand it. Buzz, how are you understanding it?
Not bad.
So that's all there is to it. So now it's going to try to move to -1 and 1 just to see if it works.
Okay.
So, you know what? That's all the functions that we need for our enemy for the time being. So let's go ahead and go back to Sprite and implement our idle update. So let's go to Sprite.h, and if we come down to, let's see if it's in here. We haven't defined it yet, so we're going to need to define it. So it's going to be vertical, no, virtual, void, idle, update. If I make any spelling mistakes, please let me know.
Oh, we always do.
Yeah. It usually starts with a little giggling.
Oh, man. So inside of here, we're going to say void, sprite, idle, update. And inside of here, void.
And you'll notice...
Nothing.
Nothing.
Nothing. We're not going to put anything in here.
It's for future.
This is for the inherited classes. Simple as that. So, if we try to compile this guy, dink. Use of undefined type enemy. Now, we do need a few things
type
on the...
character.
Type character. Yeah. I wonder what that means. Maybe it means
we
we should
include something.
Maybe we need to include character.h? Is that going to do it? And we also have direction undeclared identifier. The reason for this is vector is undeclared at this point. So we need to make sure that that's declared as well. So we can include level.h, which, if I remember correctly, is going to allow us to have access to that. Oh,
it's
I
in
remember.
Sprite, is it not?
Is it in Sprite? Let me try to remember for a second here. Din, 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 din. Is it in Sprite?
Go to Sprite.
There you go.
Sprite, you're right, my bad. So inside of here, what we're going to need to do is include sprite.h, right?
Yeah, we might as well.
And we could just include, well, we haven't included, my bad. So in here we have...
Did you spell it right?
What did I spell right?
Direction, undeclared. Go down to that line. Vector.
Oh, I spelled it wrong. That's my problem. Man. Okay.
Well, see, I was wondering because character includes sprite.
Right. Yeah.
So it should have been defined.
That's what I was thinking.
Yeah,
too.
but
Man,
we fixed it.
We fixed it. Okay, my bad. So now we have square root, rand, and rand. So square root is a math function, right? So we need to include math.h. So math.h.
And since
wait, let's get rid of those errors first.
Oh, I'm sorry.
So now we have rand. So that means we need to include what, Dan? You should remember now.
Stdlib.h.
Wow, you actually knew. That's so awesome.
I remembered from 5 minutes ago.
We also have an argument conversion from int to float. Now, if you guys don't know how to fix this, I'm going to virtually smack you.
Virtually.
So we can convert this to a float. And
Joel's using the C++ way.
It was just,
which is casting, then you put parentheses around what you want to become a float.
And that gets rid of our warnings.
Beautiful.
I'm happy now. All right, so now we need to be able to use our enemy, don't we? We
need to be
able to use
because we want to be able to see it on the screen. We want to be able to
use it.
Yeah.
So let's go to our level.h. Ding-a-ding. And we need to add enemies to this guy, right?
Yeah. Actually, before we do that, just jump back to the notepad, just so we can get a feel for what we've accomplished. And so we did everything up top.
Yep. All of this is pretty much done.
And so now we need to add the enemies to the level.
Right.
So we'll be adding the add enemy functionality, which will actually populate the level with enemies.
Right.
We'll be adding the add NPC, which...
Non-player character.
Non-player character. We're going to make a list, right?
Yep.
And this is a standard library list. So it's like a bag that we're able to put sprites into in a specific order and also take them out in a specific order.
Okay.
And that's what that functionality is going to accomplish. We can put it in the bag. And so since an enemy is a sprite, we'll be able to call its idle update function constantly. We'll be able to process and do all that stuff.
Very nice. So we're going to be doing that as well. So if we go back into our evil monkeys, first thing, in our level.h, we're going to have to add character. Oh, add enemies, right?
Yes.
So inside of here, we're going to say void add enemies, and we're going to pass the number of enemies that we want to add. So int num. And we're also going to have a add NPC, right?
Yes.
So we're going to have add NPC. And we're going to pass it a sprite pointer that we want to add.
Yes.
And we can just call this SPR.
Because we're going to have to make the sprite before we can put it inside of the stack. Inside of the stack, we have to actually create it ourselves.
Yeah, that makes sense. Another thing that we're going to need to do is have a list of the different characters that we want to put into it, the different enemies.
Yes.
But which is going to be a list of sprite pointers.
Yes.
Now this brings up something a little bit complicated to a lot of people. And please don't freak out about this. It's not that difficult. We're going to make this section public. And now this is going to put in public variables that we want to have access to.
Yes.
Now this is going to be a list. All right? So just like it's a data type. But this list, this is called, when I use these angle brackets, that means that this is a template class. Template class basically just allows us to create a class with different data types. So this class is going to have maybe integers. And inside of the angle brackets, we would say it's an integer. If we wanted this class to contain doubles, we would put double, right? Well, in this case, we want it to contain sprite pointers. So we're going to just put sprite pointer.
And just so everyone's clear, list is actually a class that is supplied inside of standard C++.
Right. So we're going to have to include that as well.
We're going to include it, but I just want everyone to know we're not actually going to make list.
No.
We're going to be using it.
Which means for those that want more information on lists,
go to the help file.
Quickly select and the good old F1 and all that stuff. And start reading about it.
Good stuff. Oh yeah. So inside of here, we want our list of NPCs, which is our non-player characters.
Yes.
Which is going to include our enemy. And to loop through this list, we want to have an iterator. And now just think of an iterator as something that allows us to go through a list. Okay, it's like you have a grocery bag, right?
Yeah.
And somebody has to be able to go through that grocery bag. And only the person that bought that grocery bag really knows how to go through it. And an iterator is someone that knows how to look through that grocery bag. Otherwise, if someone else looks in it, they'd be like, oh my gosh, look at all this stuff. What is all of it? You know?
Yep.
But an iterator knows how to go through it.
It'll go through it one by one by one.
One by one by one. So we can say sprite pointer. It's also a template, so we need to know this person, what kind of person can go through it. It's going to be an iterator, but it can go through sprite pointer bags.
Yeah.
And then we just use : and we call this guy an iterator. You don't need to worry about it. It's just that simple. So we're just going to call this iter as an iterator. Now, if we try to compile this at this point, we're going to get like 1,000 errors.
Well, wow, maybe less than 1,000.
Yeah, almost 1,000. Give me some slack.
Okay. Slack.
We're also going to need to identify Sprite. So we're going to use the same method we used before and say Sprite. This is going to get rid of a few of them, not much. So now we have this thing, syntax error, missing semicolon before.
This is thinking to me.
Yes.
That we have to include a header file so that we know what a list is.
That's right. So if we include list, this is going to, again, get rid of a few things, but it's going to bring up a few as well. Well, it's not going to show this, but a list contains the list structure that we want. But we need to tell it, remember we had the using. We had the using namespace. Well, we're going to need to say using std list so that it knows that in this class we're going to be using std list. It only makes sense. So now if we run this, look at that. It's happy.
Very nice.
So now we're using the std standard list. All right. Oh, man, I can't believe I did that again. That's amazing. So in level.cpp, now we can add this functionality that we've just included. So the first thing, add enemies. So void add enemies. And this is going to pass int num. First thing, we're going to declare a temporary variable that we can use so that we can loop through it to make sure that we add the correct number of enemies. And we're going to do this in a sort of interesting way. We're going to use a while loop. Simply because, think about it, when we start throwing enemies into our level, what if we throw an enemy on a wall?
Ooh, an enemy, a monkey isn't going to like living in a wall.
No, in fact, he can't.
No.
Physically impossible activity.
Yeah.
Therefore, we're going to use a while loop to make sure that we loop until we add the enemies, enough enemies. Because if we stick an enemy in a wall, that's not going to work.
So we're going to keep a number, some count of how many enemies we've added. And if we happen to hit a wall, we can't add an enemy, so we're not going to be able to increment that number.
Right.
But when we do add an enemy, we'll be able to increment that number.
That's right.
And when the while loop is equal or is less than the number that we want, we're done.
Yep. So we're going to say int I equals num, right?
Yes.
So we have a number of enemies. While I is greater than 0. So while he continues to be greater than 0, that means we haven't added all the characters that we want. So inside of here, we're going to generate a random number that is saying the size of our level, right? Now, it would make most sense. We have our width to have a percentage between 0 and 100, right? So then we have a percentage like 90%, which is 0.9, or 80%, which is 0.8. And then we multiply that by the width of the level, right? And then we can generate a random value so that our character can be put someplace inside of that level. So we can say int x position. So the x position is going to equal random, which generates a random value. And we're going to say generate a random value between 0 and 100.
Okay, so we're getting the percentage thing again.
Which is modulus.
Yeah.
And then we're going to divide that by 100. This is going to obviously give us a value between 0 and 1. Basically between 0 and 100%, right? So 0.9 would be 90%. But this random returns an int, as you can see in the little dialogue right there. We have int, which means an int divided by an int. What's that going to give us? An int, right?
Right.
Well, we want a floating value. We want something between 0 and 1, which has point values all over the place. So we need to change this guy over to a floating value so that we can have decimals. So with that, now we can multiply this entire thing. So let's put quotation marks around this guy as well.
Quotation?
I mean...
Parentheses.
Parentheses. That's what I meant. I really did. We multiply this by the width of our level, right? And did I name it width?
It was...
Yes, it was width.
I would suggest that you see on line 84?
84.
You didn't add the level.
My bad.
That way we're not going to get into some compiler issues when we decide to compile.
Yeah, thank you.
Yeah, you're welcome.
And remember, our level has a wall, right? So there's one line, one column that has a wall, and there's the other side that also has a wall.
Which would be the leftmost and the rightmost.
Right, so that's two extra sections that we don't need to account for.
Yes.
So we want to make sure that he isn't generated in the sidewalls, because we can prevent that. So we can say width minus 2. So those two we don't need to worry about. But then, here's an interesting thing. We're going to add 1 to this as well, because remember, it's 0-based, right? So the first one is going to be always a wall. 0 is always going to be a wall. So if we add 1 to that, we're never going to hit the left wall. So that is our complicated, immensely complicated formula.
So just sit down if you need to, get some paper, and write some numbers down, and start figuring
Look at it, meditate over it.
Yeah.
Hang it up on your wall. I don't know what you want to do with it, but just, have fun with it. So from there, now we have the X and Y position.
Yes.
Now what we need to do is check to make sure this isn't inside of a wall. So we can say level. We have the level data, as we talked about before.
Since we're in level.
Your X position and Y position are ints.
Yes.
You need to cast that back to an int.
I can cast that back to an int. It's going to give a warning.
Okay.
So I'll cast it back to an int to make Buzz happy. So I'm casting it back to an int. Get all our data types. Warnings are a bad thing.
In sync, yeah.
Yeah. So now X position and Y position are going to all be good.
Okay.
What?
Oh, there's an in sync. I didn't quite understand how the band came into this, but hey, hey, whatever.
All right.
Just keeping everything in sync.
Oh, man. So we want to make sure that the current position we're at is not a tile wall. And then we're going to make sure that X position does not equal 0 and Y position does not equal 0, which it shouldn't. Actually, you know what? We're just going to leave that out for now because I think that should work fine.
Okay. I'll go with that.
You'll go with that.
I'll go with it. Okay.
Now that we have that, we know that we're in a valid position, right? So why don't we put an enemy at this position? So enemy.
So we're going to use our new keyword to make a new enemy in memory.
Yep. So new enemy, and we're going to pass it us, which is what, Dan? This. We talked about that before. We're also going to pass it draw engine, which is our draw area. And then we're going to pass it the sprite index, what we want to print out.
Yes.
And this is going to be sprite enemy, which I think we still need to define. I'm not sure. We'll look back at that. So sprite enemy.
Yes.
We also need to specify the position where we want to put it. Obviously, we've already got that, so we're just going to say float X position, float Y position. How many lives do we want? Let's just leave that at its default, 1.
Yeah, because if we shoot an enemy or something, we kind of want it to go away.
Yep.
Yeah. So 1 life is good.
Yep. So now we're going to say temp, which is our enemy. We want to add a goal. And what do we want to add him as? We want to add the player.
Right.
Because that's the good guy.
Who he's going after.
Yep. Now we're going to use our function add NPC. This is going to add it into our list. We didn't want add enemies to handle everything because that's too much. So if we have a function, our add NPC function, it's just going to add it into our list of enemies.
Yes.
Or our sprites, our NPCs, whatever you want to say.
Yep.
So now we have sprite pointer, and we're going to cast it to a sprite pointer, and it's going to be temp.
Now this is important because an enemy pointer is not a sprite pointer, but an enemy is a sprite.
Right.
And through typecasting, we can make sure that we don't get any compiler errors or any other
warnings,
any other problems. So sprite pointer, since an enemy is a sprite, we can cast it like this.
That's right. So from here, we also want to make sure that we decrement I, right? Otherwise, we'll have an infinite loop.
Yeah, because we have a free space. We added our player, or added our enemy, added our enemy, and so now we can decrement the I.
That's right. So from here, we now need to add our add NPC function. So let's go void level. This is going to be an easy function. Very easy function. As long as nobody freaks out. So Buzz, don't freak out.
This is just a matter of understanding how list works.
Yep. So NPC dot, and you'll notice that all these functions here come with our list. And we're just going to say push back, and then we're going to throw on our SPR. Right? Now, a stack. Buzz, what is a stack?
A thing you can stack things on.
Right, well, if you think about, let me see,
a pile of books.
A pile of books, right.
That's a stack.
That's a stack. You put one book down, and you put another book on top of that.
You now have a small stack.
And then you put another book, another book, another book.
Your stack is growing.
Your stack is growing. Usually you wouldn't want to take the book that's on the very bottom off first.
Unless you're good.
Unless you're really good. Especially if they're really big books.
Yeah, exactly.
Yeah, that would be hard. So you want to always take the book that's on the top off first. That's a stack. That's all there is to it. And when we say push back, that means we're putting the book on the very top.
One of those first in, last out type situations.
Yeah, exactly. So that is our add NPC function. Simple enough. Now, what else do we need to do? Let me think. Is there anything else we need to do? Our update. What does our update function need to do? It needs to loop through every single one and make...
Every single one being the list of
every
sprites.
Single NPC.
Yeah.
And call its idle update function.
Yeah, because we want the enemies to be able to think.
Yep.
And that's taken care of in our idle update function, which calls the simulate AI function, which calls the move function.
Yep, that's right. I was hoping Dan would get through that one.
Yeah, well, sometimes it takes me a while, but please continue, Joel.
All right, so we're going to use our iter function now. As we said before, our iterator lets us go through our list.
Through the stack.
Walk through the stack. So iter, remember, that's our iterator. And we're going to say npc.begin. NPC, it returns to us the beginning of the stack. Then, again, this is a for loop, so we're going to have some sort of check. If we're not at npc.end, we're not at the end of it, then we're going to say iter ++, which goes to the next one.
Stack.
Yep. Isn't this simple?
Yeah.
So inside of here, we're going to say iter, because remember, what is iter going to point us to? It's a pointer to a sprite, right?
Yes.
Yeah, that's right.
So if we dereference it, and then, dink, now we have...
Oh, hey, look, it's all the sprite functionality.
This is all the sprite functionality. So, of course, we want our idle update function, don't we?
Yes, we do.
And we're just going to call it. Simple as that. We're also going to have another thing. If... We're just going to throw this in. It's not going to work yet, but it's needed. If it's not alive, if is alive, equals false. So that means our enemy is dead, right? We want to kill him, right?
Yes.
And we do not... This is not going to be useful yet, because, well, does our character have any way of killing them?
No.
No, he doesn't. But this is in preparation for the future, when we have a way to kill our sprite. So at this point, what we're going to do is say sprite...
Well, actually, we could kill our sprite by just saying add lives -1 inside of our code someplace.
Yeah, but we don't want to.
But we don't want to.
No. So we're going to say sprite temp equals star iter. Star iter, remember, gives us the pointer to our sprite.
Yes.
Right? So that's set. Now we're going to say iter --, which just backs us up from the list one, so that our iter is no longer pointing at the current one.
Right.
Because if we deleted it while we were pointing at it, then, well, we stop pointing at anything. Then we kind of just break up and die.
It's kind of like we toppled over the stack of books, and, well, it's a mess on the floor, and we don't know where we were.
Yep, exactly.
Yeah.
So after we decrease it, now we're not pointing at that guy anymore, but our temp is still pointing at him, so we can delete him. So we can say delete temp, temp, and then we can say npc.remove, so remove that from the list, temp. Simple enough.
Yeah.
So there we have it. Now if we try to compile this, let's hope and pray that I didn't make too many mistakes. Okay. Syntax error. We need to add functionality so that we know our enemy exists, right?
Well, is that just a matter of including the enemy?
Yes, it is a matter of just including the enemy. Yeah.
Yeah.
So let's go up to here, and we'll just include that right at the top here. So include enemy.h.
Yeah, because inside of the header file, if I'm not mistaken, we used class.
Right.
Yeah.
And of course, like I was saying, sprite enemy is an undeclared identifier. So what we need to do, let me see, where did I declare?
It's in Sprite, I believe, is it not?
Yes. No. No.
Is it in level?
It's actually in game, I believe.
Oh, it's in game.
I do not remember exactly.
We're just getting a little lost here, folks, but you know what? We'll be with you in a second.
Actually, I don't think we declared this yet.
No, we didn't.
No, we did not
need to
declare
do that.
This. So what we're going to do is go into our level.h and actually declare this. My bad. It doesn't exist yet. I think it exists. Isn't that strange? So we're going to declare an enum, okay? And inside of this enum, we're going to have the different players. We have our sprite player. We have our sprite enemy. We also have our sprite fireball. That makes sense.
Yeah, because what we did before with the tile, the empty wall, and the empty in the wall,
right.
We're doing the same thing with when we say create sprite.
That's right.
We want to have a sort of automatic ability to just add different types of sprites and reference them, which is something that we hard-coded up until this point.
Right, and now we're not going to hard-code it anymore. We're going to be good people. Yeah.
And Joel added the fireball just because that's coming up shortly.
That is coming
and we
up
don't want to run into this again.
We don't want to run into this again.
A beginner keeping an eye on this, one of the things they're going to be real paranoid about is their memory, right? So there's no memory leaks, and we just saw you use the word new a minute ago as you're adding in new enemies, but we're not
deleting it
to take care of that memory once we're done.
Yeah, that's exactly right.
But,
so, what?
Okay, continue.
No, you continue.
No, please.
Okay.
Let us all.
Okay.
You open the dialogue again.
Oh, man. So at this point, what we're going to need to do is make sure that we delete everything, right?
Yeah.
And we can easily do that by simply looping through at the very end and making sure that everything is deleted from our level class.
Yeah.
Does that make sense?
Yeah, sure.
So in the destructor of our level, we need to loop through and delete everything that's currently in our list, which means that we're going to have to use the iter function as we did before. So if
when you kill an enemy,
it deletes it.
It deletes it.
Yeah.
Wouldn't that?
Effectively, yes.
You'd think. I mean, in the destructor for the enemy class.
Yes, actually, you're right. Yeah, my bad.
I mean, it seems like that would make more sense as opposed to managing it in the level.
Right.
There's two ways to do it.
Yep.
Right. What we basically have now is the idea. Well, when the enemy gets killed by something, it's going to die.
Right.
Right. So which means inside of level, it's going to be deleted.
Mm-hmm.
The other thing that we could do is just to do make sure inside of the level destructor we can say make sure all of the list is empty.
Yes.
If it's not empty, go through and actually delete everything.
Right, but at this point, we can safely assume that everything is the way it should be. Everything is being deleted properly.
Yes. I would say yes.
Yes, I would agree.
I'll say yes just so there's three of us say yes.
Right.
But Buzz, that was a good catch.
Yes, it was.
But everything will work out in the end.
Right.
So
at this point, what do we need to do to make this guy function properly? Well, actually, you know what? The only thing we really need is to add in our enemies. And then we pretty much got it. Although one thing we do want to do is in the create sprite, at this point, what do we have? We have sprite player, right?
Yeah.
And we also have our sprite enemy, don't we?
Yes, we do.
So we can come in here and say create sprite, sprite enemy, right?
Yeah, and we need to change the image for the player
to 0. Or is it 1?
It's 1.
It's 1, my bad.
If
1
you,
is the smiley face.
If you do a look for the ASCII table...
As a matter of fact, we can search for that real fast, because we can also go ahead and change the
wall tile, yeah.
Yeah, so we can get everything...
If I can remember how exactly... ASCII character codes, if you guys see it, let me know, because I always have a hard time.
I think you probably scrolled by it if you did.
If I did?
Yeah.
Okay.
ASCII class, ASCII... This is always a bit of a headache for us.
It's right in here.
I can't read that fast, but...
ASCII character codes, there it is.
Wow.
But Joel can.
Okay, so here we have... This chart is actually not going to show us that particular one, but if we go to chart 2, you'll notice that right here we have 176, 177,
we want to use
219.
Yes, 219.
219.
Because that will actually show up white on the screen.
White wall, yeah.
So if we go back to our game, so this one right here should be set to 219. Correcto?
It works, yeah.
And now we need to add our enemies, don't we? So level, add enemies, dink, and we're going to add 3. Shall we? That sounds cool.
Yes, we shall.
Yes, we shall. Dink, everything worked. Let's see if this works.
Yeah, please.
Oh, dude!
Whoa!
Yeah!
Wow! We're moving real fast. But we have enemies, if everyone can see them.
They are staying on you.
They're a little bit too fast.
Yeah, because we didn't divide the magnitude, did we?
No, we did not divide the magnitude. So at this point, they're extremely fast. Extremely
And their
fast.
walls look far more sexy.
Yeah.
Get everybody's attention off the crazy monkeys.
Buzz likes to make everything sexy.
That's right.
So one thing that we need to do is go into here and make sure that our enemy, the magnitude at this point, it's 1. But it's way too fast at this point.
Yeah.
So what we need to do is come into here and make our magnitude divide by a larger number. So that means multiply magnitude by a number. Maybe like
5ers.
But no, like something big.
Oh, real big.
Yeah, like maybe multiply this guy by 5.
Yeah. That will slow them down a little bit.
That will slow them down
quite
a bit.
Yeah. I was thinking backwards.
Right. So if we come into here and let's run this. Oh,
look at them. They're much slower now.
But they're like really smart.
Yeah, as you can see the vector math and that they can go diagonal through walls. They cheat. Why?
Yeah.
And
they're
look at
evil
another
monkeys.
thing they're doing. Let me get to a good function here, a good position. Notice that at one point there seems to be only 2 or something. Okay. They're going a little too fast for me to prove this, but at the moment, these sprites can go into each other. Look, those are actually those are together.
That.
Yeah.
Because the problem that we have here, we just commented.
Yeah, we didn't actually.
We didn't check for bumping.
They're still running into each other.
Right.
Yeah.
So what we need to do is go back into our level. No, our enemy. Yeah, where we are right now.
Project management. Okay.
Yes. Good thing we have that big picture.
Yeah.
Which encapsulates everything we need to do. So inside of here,
it's a clean concept. Anyways, you had to get all the magic words in.
Yeah, dude.
Actually.
So So what we need to do is loop through every single enemy and make sure that we don't bump into any of the other ones, right? So we're going to create a list, sprite pointer, and we're going to just declare a local iterator, okay? So that we can use this iterator. Whoa, no!
Not iterator swap, just iterator.
Iterator, iter. Thank you. And create our for loop just like we did before. And it's inside of our level, right? So inside our level we have the variable NPC, which is a list. And we're going to say begin, just like we did before. And while it does not equal level pointer NPC dot ending, and then iter plus. Now, we need to make sure that they're not running into each other. So, first thing we need to make sure is we're always running into ourselves, aren't we? That does make sense.
Because we're on the list. We're an enemy on the list. Eventually, we will see ourselves on the list.
Right.
And we don't want to see ourselves on the list because we can't bump into ourselves.
That's right.
Unless we trip a lot. But evil monkeys don't trip.
Evil monkeys don't trip.
Yeah, so we're not going to bump into ourselves.
So we need to say iter, which is the one that we're currently looking at, does not equal this. So that gets that out of the way. And int, what we're going to do is check get x, get y, and make sure the positions
are not the
same. So the first thing we're going to need to do is say, let me get rid of this for a second. Okay, sorry. Iter get x.
One of the accessor functions from the Sprite class.
Equals x position, which is ourselves, our current position, right? As we defined right up here.
Yep.
And star iter. Man, I'm not being able to type anymore. That's okay. Star iter. Thank you. Man, all that typing. Okay. Equals y position. Okay? So that means if we get into this if statement right here, that means we are on the current position, aren't we?
Yeah, because we're not ourselves. We haven't bumped into ourselves.
But we are on top of someone else.
But we are on top of somebody else.
And that's a bad thing. So we need to return false, which means we can't move to that location.
No.
Otherwise, we just continue through and we're fine, right?
Yep.
So with that in place, let's Control-Shift-B, and look, everything works fine. Wow, that's awesome. But another thing that I do want to do in here is I'm going to just cast these guys to integers. Because if you think about it for a second, because of our magnitude, we could have a float, right? We could have 32.235, right?
Okay.
We want to make sure that they are all rounded to a current position. Otherwise, you would have maybe the get x for our other enemy is 2.5. The get our x position for this one is at 2. Well, 2.5 and 2 aren't the same, but we only have cells, right? So if we need to round it to an integer before it will work.
Yeah, we want them all to be on 2 and 2.
Right. So let's round this guy because get x returns a float. So let's cast this guy to an int and cast this guy to an int. Our x position and y position are already integers, so they're fine. So if we Control-Shift-B, we didn't get any errors or anything or warnings, but just that is important to keep in mind. Otherwise, they'll never really hit each other. So if we run into this now, let's try to get into a position where they...
You notice they're not lining up with each other.
Look at that. They're kind of avoiding each other at this point. You always see a lot more characters on the screen. And when I start moving away, they don't all group together like they did in the last time. So that's a whole lot better.
Very nice.
So basically, that wraps up how to create enemies.
That are now trying to kill you.
Yeah, they're not trying to kill me. But they don't kill me just
they
yet.
Can't.
Yeah, they don't. Yeah. It's coming.
It's coming.
Soon.
To a theater near you.
Near you.
Yeah.
Okay, so with that's going to wrap up this lesson on the enemy class. Thanks a lot, everyone.